Hey, good morning, everyone. Good morning. Okay, quick show of hands. Sorry, test, first thing in the morning. Who here thinks that AI is going to take your job in 5 years? Raise your hand. Okay, you're out. Okay. Actually, stay here. We need you. Who here thinks AI is going to take your job in 15 years? Raise your hand. Come on, raise your hand so I can see it. Okay, so that's like 9.6%. All right, so I think that you're wrong. You're probably going to still have jobs. I think other people might have difficulties. But the fact that you're here today thinking about AI suggests that you're probably going to be able to cross the chasm in terms of how to apply AI to your life and to your work. However, I think that as AI unfolds even more, while it will crimp some people in some industries, it's probably going to be better for most people. In the same way that at the outset of the Industrial Revolution, things looked pretty bad. And towards the end, actually, we saw the rise of the middle class. And we had enfranchisement in terms of education and other great benefits. It was tough to cross from one place to the other. What I'd like to do right now is talk about business strategy and artificial intelligence. And I want to start by a story. And the story is about automotive racing. But as you can guess, you've invited someone from The Economist, but he has an American accent. I'd say automotive racing, and here in Europe, you think Formula One. But I'm talking about NASCAR. Yes, it's 9:30 in the morning, you're at the Langham Hotel, and you're listening to a gentleman with an American accent talking about stock car racing. Full-on Bible Belt Trump country stock car. So the difference between Formula One and stock car racing is in Formula One, you have all these highfalutin engineers tinkering with the engine and the aerodynamics of the car to make this super incredible vehicle. NASCAR is different. In NASCAR, it's literally a stock car. It's a car off the stock. What you're able to do to the car is very, very small. You're actually not allowed to make a lot of changes. So where in Formula One, it's engineer versus engineer, in NASCAR racing, it's driver versus driver. But, of course, it's not just the driver. You also have a race manager in the back who's making some of the decisions. And of all the decisions to make, one of the most important is when to do a tire change, whether it's 2-tire or 4-tire change. And the most important decision still to make is whether you do that when the yellow flag has been thrown on the track. Because when a yellow flag is thrown on the track, it means that there's probably debris or bad weather, and that all the cars need to actually drive cautiously, and they can't pass. So the natural distribution around the track of cars actually starts to cluster as they snake their way through together. And it's at that point that a decision has to be made, and it's a very difficult decision. Do you go into the pit to make the change or not? If you go into the pit, you don't give up any time. You're all traveling at the same speed, but you give up rank position. But you need new tires for when the flag is lifted, because tires give you speed. Fresh tires allow you to pass. So it's an optimization problem. Jam today or jam tomorrow. And race car drivers used to do this. Race car managers used to make this decision based on their knowledge and their experience and their luck and their superstitions and their instinct and whether they had tea in the morning or coffee. And they couldn't really explain why. And maybe they were good decisions and maybe they weren't, but they did know one thing: they could probably do better. And so what they did is they called Cynthia. Cynthia is not a race car driver. She's not in the pit. Cynthia is a geek, one of the world's most important. She's a statistician, formerly at MIT, where she won some awards, but now she's at Duke. And what she does is she likes to take lots of data and solve really difficult problems. And so she did that for the NASCAR teams. She looked at it. She collected all the data she could, whether it was the aerodynamics of the car, the fuel, the weight, the driver, time of day, the weather, position that you were in when you entered the pit, the position that you were in when you're out of the pit, at every stage and every lap, whether you were winning or losing, accelerating or not, what it looked like not just with you, but with other cars around. She discovered things that we never knew before, like there was like a neighborhood effect. You think that each car is like a roulette wheel, an independent variable determining what they're doing, but it turns out that when they cluster together, they actually act in a concert or a cohort. Where you are relative to a car that's going to win or lose is going to affect your performance. Strange, but it's a little bit like skiing. If you're skiing with a great skier, you're probably going to ski a little bit better. But why that should be the case, we don't know. Okay? But the key thing that she found out, the most important, was that to understand the question of whether to go in for a tire change or not, what you really need to understand was the wear on tires. And to understand the wear on tires, you needed to understand something else. And this is what she figured out. There's no such thing as a racetrack. There's race tracks, plural. And that each different track has a different effect on the wear on tires. So what to do in a given race doesn't depend on the race itself as much as it depends also on the track you're racing at on a given day. And this was never known before. There's no one answer. This isn't the rule. Here's the rule. Follow the rule. Don't break the rule. It doesn't exist. You need to optimize down to the atomic unit of the particular racetrack you were on in a given day. And what you did would be different. And as a result, teams that take her advice win, and teams that don't lose, because you race for hours and you lose by seconds. So what's happening here? What's going on? There's lots of different features to the story. The first is technology. We can do things we never could before. The second is data. We have information that we didn't have before that we can now apply to sort of make the world more comprehensible. We can understand it, make better decisions. But the third and the most important today is a question of mindset. Cynthia Rudin has the AI or machine learning or big data mindset. She understands that she can take the world and all of its complexity. She can collect as much data as she can, and she can help to make better decisions in it. It's in that way we see the world and data as a new resource, that it is, if you will, a new raw material, a new vital economic input. And we could appreciate why someone like Adam Smith in 1776 could write The Wealth of Nations and see land, labor, and capital as the three factors of production and not talk about information, not talk about data. Because back in the 1700s, it was so difficult to collect it, to store it, and to process it. And that now has completely changed. There's still an obstacle there, but it's nothing like it was in the past. And so we can think of data as a new factor of production. So what is the world of AI? What is machine learning? We can understand it in lots of different domains. We can have computer scientists tell us all about it. But fundamentally, what's going on is this. There are things we can do with a large body of data that we fundamentally cannot do when we're only working with smaller amounts of it. That a change in scale leads to a change in state. That a quantitative shift leads to a qualitative shift. Or if you prefer, more isn't just more. More is different. So how does it work? What's going on under the hood? Although I accept Pratna's injunction that what we care about is the output and the effects, let's take a quick second to think about what actually is going on in the algorithm. So the most important and the most fundamental is this issue of machine learning. AI in the 1950s, when the term was coined, represented a sort of intellectual project, almost for the psychology department and the philosophy department as much as for the mathematics and computer science departments. But machine learning really doesn't have to do with all of that. It doesn't care about that. What it really cares about is just stats. And so that's the great revival that we've seen in AI, this renaissance in deep learning, is because of the victory of stats over the philosophers. So what's going on? So the origin of machine learning comes back to this fellow, Arthur Samuel, And in the 1950s, he was a computer scientist at IBM. And what do you do if you're a computer scientist at IBM in the 1950s and you like to play checkers, or here, Britain, you'd say drafts, is that you write a computer program to play the machine. And so he does that. He plays the machine, and he wins. He plays the machine, and he wins. Because the machine only knows what a legal move is. Arthur Samuel knows something else. Arthur Samuel knows strategy. So he writes a small subprogram that operates in the background that after every move it calculates whether the new board configuration is likely to lead to a winning board versus a losing board. Plays the machine again, wins, plays the machine again, he still wins. He uploads lots of games, historical games that he can find. He still wins. And then Arthur Samuel leaves the machine to play itself. The machine plays itself, it collects more data. It collects more data, it increases the accuracy of its predictions. And then Arthur Samuel goes back and plays, and he loses. He plays, and he loses. He plays, and he loses. And Arthur Samuel has created a machine that exceeds his abilities in a task that he taught it. And this idea of machine learning is going absolutely everywhere. One place where it went was with Google DeepMind. The AlphaGo system, which was a hybrid of different sort of transfer learnings, reinforcement learning techniques, using deep learning as well, was fundamentally the same principle as Arthur Samuel's machine learning, a much more rudimentary system for the game of checkers. The world's best poker player is now an algorithm called Liberius, which is from Carnegie Mellon University in the United States. And this might be a little bit troubling for us to think about when we consider that the only way to win Texas Hold'em poker is to bluff. So we're creating AIs that are able to deceive human abilities in a task that we taught it. Likewise, machine learning is going absolutely everywhere. We use it every single day. We're not even aware of it. If I were to type into Google the name of a company founder and CEO of an AI analytics company, and I misspell the last name and I add an extra I to the last name, how did Google know? Who at Google got the facts and typed it in of exactly what is the spelling of all the executives' names of all the AI analytics companies in the world? No one does that. Right? It's a machine learning algorithm. Google scours the global internet. It does it in 0.35 seconds. It looks for instantiations of these two names, and it identifies that it's far more common to be spelled with one I as the last letter than with two in English. And of course, you know this is the global internet. There's typos everywhere, so it's just simply the law of large numbers. It simply identified it through a machine learning algorithm to make an inference that this is the person I'm looking for and not someone else with a different variant to that name. It's because of machine learning that computer translation isn't as laughable, that we have speech recognition, that we have self-driving cars. In the medical sciences, it's where we're seeing incredible progress. Recently, there was a study at Harvard, Stanford, that wanted to find out if a machine learning algorithm could perform as well as a human pathologist in identifying cancer, severe cases of cancer. So they uploaded the biopsies and they uploaded the patient histories. In fact, their survival rates in patients, they said, you figure it out. And what happened was the machine learning algorithm was able to perform as well as a human pathologist in diagnosing severe cancer, but with a problem. It was able to tease out the 11 telltale signs that best predicted cancer. The medical literature only knew of 8 of them. 3 of the things that were spotted by the algorithm were not part of the practice by human practitioners. It was invisible to the human eye, but it was spotted by AI. And that idea is going everywhere. We'll be able to learn things that we couldn't know before by applying this new tool to everything that we do. So this has been an example about hospitals. It's been about hospitals, it's been about patients. But this is not about hospitals, and it's not about patients. It's about something more. It's about thinking of the world in an entirely new way. Every sales transactions, every breath we take, every leaf on every tree, every gust of wind, every flight that takes off, every biopsy, every tire gauge in every NASCAR car, right? It's about thinking of the world as a platform for the collection and the analysis of data. So where is it going to go next? How can we actually think about AI in a way in which, in a conceptual way, to know how to expect to take it to solve our problems today, our immediate needs? So if you were to think about any technology, one way to do so would be through the lens, as an economist would, of what does it lower the cost of, right? Any technology, what does this technology lower the cost of? So you take technologies of days gone by. For example, the printing press. What did the printing press lower the cost of? The dissemination of information, right? And when you lower the cost of dissemination of information, you not only had more information to more people, but you actually created people. You have more literate population, you created new literature. So it was about increasing the overall pie, not just simply disseminating it. Sure, right? And then what about energy, right? Well, what did that technology of the turbines of electricity lower the cost of? Well, of power. It was muscle power, or was wind power, windmills, or was water wheels with the water power. That's just power. And then you could actually make it smaller and smaller. So it's smaller engines doing things that we never could imagine before. The motor. And then there's computers. What did computers lower the cost of? Well, a hint is in its name. Computing. To compute. Computers lowered the cost of arithmetic, doing math. Right? And at the dawn of the computers, the first thing that we did is we had computers prior to the electronic computer. They were the job description of human beings who would actually compute things. And things that they would compute would be like missile trajectory tables, right, prior to World War II. And then when we had a computer, we applied it to the exact same thing, just to do a better job of missile trajectory tables. But the first large-scale computing program in the 1950s, actually late 40s, 1950s, was the SAGE missile defense system by the US Pentagon. Right? But pretty soon, we took all of these cheap cycles of mathematics, of arithmetic, and we started applying it to things that we never thought had a mathematical bent to it. So we had wet film photography, and then we had digital photography. Because when the cost of doing math was just so low, we could apply it to things that we never thought we would apply it to before. In this case, taking images digitally. This, by the way, is the first digital camera. It was built by Kodak. Ask your parents. It's still around. So, AI. What does AI lower the cost of? Predictions. Inference. We had inference before. We're going to have it again, but they're going to be a lot cheaper. So we used to make forecasting of businesses in the past, and so now we do a better job of forecasting. We're applying these cheap inferences to things that we had done before, now through this new technique, making forecasting again. But pretty soon, when the cost of making a prediction goes so low, we'll do entirely new things that we never imagined we'd be applying these predictions to. For example, taking a car and having it drive itself. When the cost of running predictions are so low, you simply do new things with it that you never thought had a predictive bent to it. But if a car is a computer on wheels, and a computer can make 1,000 predictions a second, we can have a car that can identify that this is a traffic light. If this traffic light is red, not green, it means I need to brake and not accelerate. So the great infrastructure project of our day, and where we're going to be applying this tool, is to take absolutely everything under the sun, turn the problem into a prediction problem, and solve it with artificial intelligence. And that is what we will see for the next 2 decades as this one idea and technology rips through the economy, changing everything in its wake. Not too dissimilar to how computing did it 50 years ago. When we get these benefits of these cheap predictions, to all the problems that we have, and we start optimizing lots of different things, we get these enhanced abilities in the area of scale, speed, and accuracy. So let's think of one example of that, recycling. Right now, in Sun City, California, there's a recycling center and an incineration center in which they're putting in all of the trash that comes through, but they're able to sort it now and find in the material that would otherwise go up in flames in the incinerator, material that could be recycled, right? And there was never an economic model to have a guy in a high-vis bib actually pull, recyclable plastics out of a big chute that's going through into recycling center. But now with a machine learning algorithm, you get a little machine, it goes there, machine vision actually can identify that this sort of plastic is recyclable versus not. Robotic arm comes out, puffs of air, grabs it and puts it aside. It's able to do 1 pull per second, right? 365 days a year, 24/7. Okay? And by doing so, it can reclaim so much plastic that it almost pays for itself after 1 year of operation, and then you still have the machine. So people will say that, hey, AI is going to destroy jobs. Yeah, some jobs will actually be crimped. But at the same time, it's going to open up whole new areas of the economy in which we're able to create new forms of value that we never could before, save the planet at the exact same time, right? These are the ways in which we're going to use our imagination to apply this tool. Another example is banking, right? The Bank of China loves to make loans, loves to try to identify, who's a good credit risk and who isn't. But the Bank of China has a problem. It's a data-starved environment in which there's not a lot of information about who's who. If you're the Bank of China. If you're Alipay, however, and most people have it on your phone and you can actually see the transactions that customers are using, they do a better job of being able to make an inference whether someone is going to be a good loan repayer or not based on how they've handled money in lots of other contexts around their lives. Right? If they travel a lot, if their salary is going up or going down, or if they're spending too much relative to what they're probably earning or if they're not. Lots of different things that you can infer. You'll be able to find economic enfranchisement by identifying where they're living and then when they're moving to another place. Are they taking out more loans because they're more wealthy, they're in a better neighborhood, or are they taking out more loans because they can't afford things because they're now living in a less good neighborhood? These are the things that you'd be able to infer simply by tracking the data. And then there's this idea of complexity. The world is a complex place, and we can't always know what the best decision is in it. But with more information and this new tool, machine learning, we can do new things. And one of the things we can do is spot patterns that humans would otherwise miss. So we saw that when it came to biopsies and cancer. Now you can think about it when you think of the global economy. There's a company in Boston called Cargometrics, and what they do is basically they're really good at counting. But what they count is every container ship in the world and where it is at a given time. And because they have all the historic data, they know where it's been going. And because they know where it's been going, they also can infer what its cargo is. This one has plastic toys from Taiwan. This one has oil, right? And they can actually have a lens into the global economy before the global economy's production stats have come out, because they can see the international trade going around the world. Now, of course, the data is very messy, and you can already see it looks like there's a tanker that's in the middle of Mongolia and one in Russia. And the reason why is that although all ships of a certain tonnage have to broadcast their location, they can spoof it. They don't have to broadcast it honestly. But if you think about it, it's actually in some ways more interesting if someone is trying to actually sort of mislead where they are. And of course, one of their big customers is intelligence services who want to see who's trying to deflect attention to themselves. And you know which boats are regularly trying to do that, either because of the cargo or because they're doing something naughty. Likewise, to understand complexity, is we're able to actually, if you will, search the entire solution space of a problem to find out the best answer to that problem. And one really interesting example comes from Airbus. Several years ago, they wanted to create a new cabin partition for one of their new planes, and so that they had the design constraints that they needed in terms of weight, in terms of strength, and in terms of size. And normally what you do is you give it to a designer, they'd come up with a couple prototypes, maybe 15, maybe 50 if they wanted more. Instead, they gave it to what's called a generative algorithm or an evolutionary algorithm. It's one which actually creates a design, tests it, and then creates a small permutation in one direction versus another, sees which one does better, and then builds on it again and again with these small incremental changes. Instead of having, say, 15 or 50 prototypes for their cabin partition, they had over 10,000. And the final one that was created looks like this. Now, you don't need to know anything about aircraft design to know that a human mind did not come up with this. This is not something that some sort of designer is going to noodle over the course of 3 weeks and then say, here are the plans. It's an alien form of intelligence that created this. But it's lighter. It's half the weight of the typical cabin partition design, and it's twice the strength of the typical cabin design. And again, if we think that this is a good thing because if we have a less weight of an aircraft, it uses less fuel, and therefore we get this benefit for the environment. So too, again, this didn't destroy someone's job. It actually gave them superhuman powers like Iron Man to do their job better. And you get this special sort of social benefit at the end of the day as well in terms of the fact that we're using less fuel. Using less fuel means that probably the cost of air travel, hopefully, is less expensive for us as consumers. These are the sorts of things that we're now able to do when we apply the technology of AI to all of our problems. But it gets more interesting still, because if the world is indeed a complex place, and this technology can spot things that we ourselves, with our 3-pound cabbage-sized brains in our skull, right, and our distracted attention and the limitations of our eyes and the limitation of our cognition, if we can shuck all that away and have this new form of power, thinking about things and spotting things that we can't see, we can probably uncover brand new things that we didn't know before. It was only 150 years ago that we understood the electromagnetic spectrum, yet the electromagnetic spectrum had been around our spheres for millennia, actually longer than, of course, for millions of years, if you think trillions because of the Big Bang. Fine. Be it as it may, we had Adam Smith coming up with theories of the economy. We had Aristotle, theories of man, and Plato, right? But we didn't know the most fundamental thing that we use every day, which is the radio spectrum. So what new law of physics, what new aspect of physical reality is circulating our spheres all the time that we're unaware of, that AI is going to be able to spot for us, that we ourselves are not going to be able to identify without this tool? You have to ask your questions. What would it be? There's probably going to be something. What will we be able to do with this that we can't do today that will be pretty fundamental in 50 or 100 years? If we know that dog owners, when they hear the bark, can tell if the bark means I want to go out, or I'm hungry, or if there's an intruder. And likewise, a mother can hear the squeal of a baby and know that the baby is probably wet, or just wants to be cuddled, or is hungry. So will we be able to use this tool to identify the patterns of animal speech and to have a sort of rudimentary way of communicating with dolphins? I don't think we're going to be talking about Kant's metaphysics to spiders, but I do think that I'd be really surprised if in the next 50 years that we don't have a way to communicate at a certain level with animals, with certain animals who have the cognition to be able to do that. In the same way that if you take a newborn child at 3 weeks old, you try to actually have some sort of communication with it, not going to happen. You take my 11-year-old, maybe you'll get a flicker of cognition out of her. That's a joke. She's brilliant. She's lovely. I'll show photographs of her next. Okay. So what are the implications of all of these new tools that we have and all these new ways of thinking about the world by applying AI to it? And the first one is the idea of DNA, of encoding and of sequencing that code. For the last 15 years, we have been sequencing the human genome. But what we're doing now is we're looking at all other aspects of life and business and society, and we're extracting a genome for it as well, whether it's diagnosing cancer or understanding the economy. At the same time, it's forcing us to rethink who we are and what we can do. We're no longer the sum of all knowledge of the universe. If anything, we're just a small pale blue dot, as we always were. And we need to be more humble about how we know what we know and how we interact with the world. At the same time, for companies, I think it's going to press upon them that they need to be, if you will, the Roomba company to succeed. And that is to say, like a Roomba, you need machine learning to do everything you do. It's not that you have the answers, because the Roomba actually doesn't know anything about the room when it sets out. But it's able to vacuum the entire room just by simply course correcting in a very smart way. If you will, it doesn't know, it learns. The point about machine learning is basically the Bayesian statistics approach to life. In Bayesian statistics, it doesn't say, hey, I know the answer. Everything becomes very probabilistic. It simply says, I'm going to collect more information at every step to update what I think I know about something. And companies that apply that Roomba mentality don't have to know the answer. They just have to, what Peter Drucker said, the business guru, learn by doing. Take a step, like the Roomba, make small mistakes, and eventually find your way through trial and error at a hyper scale to get to the right answer. That's what machine learning is all about. So what this means is change. Change in people and the organizations that they work for. What you need to know changes. Who you need to work with changes. Right? Who your partners are will need to change. And there's a new advantage, but it's unlike the dot-com era 25 years ago, in which the advantage shifted to the upstart and to the startup and to the company that was unencumbered with business models of yours so they could think about the world in a digital setting. In a world of AI, actually, the advantage shifts the other way. The advantage shifts to the incumbent, to the legacy player, because they're the ones who have the data. And they also probably have the balance sheet with which to invest in how they harness that data and put it to use. More importantly still, if you only take the data and you apply it, you're a fool. Because the data is going to be really relevant and the business problems are really going to be solved when you take the data and marry it to professionals who've been in the weeds of an issue for a long time and sort of have developed a sixth sense about what to do, what matters and what doesn't. And it's going to be that combination between data and people that's going to show our performance. So how do you start? I'm asked this all the time. And I'd say that when I thought about it, I thought there was about 5 different ways to think about what to do in a very practical level. The first one is learn to count. Right? I am struck by how I will travel around the world and I'll talk to lots of people about what their problems are and what they're doing, and to realize that they actually don't know the very basic elements of their business at that atomic level of being able to count what happens, whether it's their sales transactions, whether it's their clicks to their website, whether it's the number of people who not have just come through the top of the funnel but come through at the bottom, or where they've ended up when there was a pain point and then they left the process. Just learning to count, to take everything that happens in a business and put a number to it, is, you would think, would be from like 1910, the great age of statistics, Fisher and Pearson. It doesn't happen. So learn to count. You have to invest in your IT resources to do that. Who can actually go to the board and say, hey, we need to put money in this really rudimentary, boring thing? Like, everyone wants things that are sexy. That's a problem, so you have to really show some sort of corporate, jiu-jitsu to get people to pay attention to the boring stuff, because you can't build it if you don't have the foundation right. The second is self-service. We always like to say, hey, we're going to have this data science team, and they're going to do it for us. We've hired this guy, he's a PhD, worked at CERN, he's really smart, it's his problem. That's always a recipe for failure. You have to have people who are at their laptop, at their desk, who can actually do some of this themselves. And even if they can't do it, and they have to rely on that guy from CERN, they have to be wise enough to realize that it's important, they have to know about it, and feel really comfortable talking to that guy at CERN, or who used to be at CERN. Okay. The third thing is getting wholly novel data. Okay? Often, someone's going to sell you something, a piece of software, the IT people who sort of connect the wires to your boxes, and they say, oh, here's what we can collect. But what you're doing, if you accept that, is you're presuming that some guy, some 25-year-old in Silicon Valley in 1999 knew your business better than you. Because they said, oh, here's the default settings. And there's some IT manager who says, here's the numbers that came through, or some data analytics team, 22-year-old, who just presses the button, hits return, and then gives you a PDF of a report. Don't trust it. Look at your data. Think about it. You look at your business, rather. Think about it in as rich a way as it is of what brings you passion. what your customers absolutely love, and then say, what do we need to know? What do we really need to know? And if they say, of course, the reaction is going to be, we can't get it. You say, that's fine. Don't tell me you can't get me that data. Tell me how you're going to get me that data. If it takes 3 months to get it, take 3 months. I got the time. But get me the data that I need. So try to come up with wholly novel data. We did that at The Economist. I brought the team together at the beginning of a couple years ago on like January 3rd on the Monday back. And I said, boys, not just boys, but they like it. I said, boys, this year, once a month, I want us to come up with something that we measure and report back on that has never been measured in the history of journalism before, right? So I don't care what it is, get it for me, right? And they did. And one of those was just the cover. We looked at the different colors on the cover, whether it was a photograph or an illustration, whether it was funny or whether it was serious, right? And we could learn new things we never knew before for the pure sake and love of counting things and understanding it, but it created new dialogues and new insights. Like if we had a business person and we had, say, 8 business people on the cover over the course of a year, and every single one of them was a guy in a suit, it made you think, hey, gee, maybe we should do something different, right? Not saying I've got any agenda here, but you might want to imagine that this starts a different conversation. The final 2 are these. The first, look for small wins, don't look for the big wins. The big wins will come in time, but prove your abilities with small wins that just get people along with you on it. And the final one is, and I see this problem all the time, come up with a budget. So when someone has a good idea, a little auxiliary budget, when someone has a good idea, you have the resources to invest to do it, right? I can't tell you how many times it's such a sort of a spirit killer in an organization where young people who are doing something realize actually what we're doing isn't the right thing, we really need to be doing this as well. So they have to wait until January to get it into the annual budgeting cycle so they can get the budget on April 1st and they don't even get the money until June. Like the 2 people who came up with that idea now work for someone else, right? So it never happens. So you need to actually pull out that resource of dosh, of money, that you can then plow into good ideas when they come up throughout the year, okay? If you will, it's not just about starting, this is just about leadership. This is just about taking a leadership view in terms of how to implement AI into your organization. Now, I've been very positive about the world so far and how the AI is going to unfold through business in a very good way. There's risks as well. I talked about jobs, and I think that's going to be a serious issue, but I also think that it's overblown today. AI is going to work best when you have smart people working with it to get the best out of their organizations and out of their staff. The second, though, or if you will, in here, the biggest risk is going to be privacy. We have seen the difficulties of how applying data and AI in the commercial setting has affected companies. And we can only imagine what the world's going to look like in the future when, if we don't have a baseline degree of confidence in the system, people are going to reject it. So we need that baseline of confidence. I don't think that Europe's policy is the right one. I think it's too strict in the wrong ways and too loose in ways that you do want to control data. But it's a pretty good place to start, in part because what it forced every company to do was create an inventory of their data assets. So that's a great thing to start off the AI economy by doing. So I at least congratulate that. But it's also something to build on, as long as it's flexible enough to work, to sort of to be built upon and enhanced. The critical issue that's going to go on is data ownership, particularly because America goes in one direction and Europe is going in the other. Who owns this data? Is it the company that invested in collecting it, or is it the person from whom it was taken? We don't know the answer to that yet, and it's going to be very, very difficult. Will it be a property right, like an intellectual property right, like copyright or patent, that attaches to oneself just by dint of sort of drawing a dab on a canvas? If that's the case, you're going to have a thicket, and it's going to be hard to actually do things with that data and aggregate it for socially beneficial things. We don't know the answer. Thirdly is propensity. Will the world turn out to be like Minority Report, in which we'll be making predictions about what's going to happen before people have actually acted, and we'll penalize them for their propensities? In the criminal justice system, that's a real risk, but we do this all the time when it comes to credit ratings. How are we going to adjudicate the world that we want so that there's fairness and moral choice and moral agency and human agency involved? Finally, it's the question of explainability. These techniques work, but we don't know why. The best performing AI algorithms are obscure to us because the math is too complicated to unwind and give an explanation about how it came to its decision. But if we don't apply it, we create other problems. If I can tell you that that the best standard of care to diagnose a certain disease is 90% by humans using statistics, but it's 91% accurate when I apply deep learning, do we really expect that 1 out of 100 people whose life we can save, we're not going to because we can't explain why we came to that conclusion? The person who's saved will always be grateful, but the person who will be mischaracterized, if you will, that those 9 percentage points of people in that statistic will always feel aggrieved. So we don't actually have this institutional practices and cultural, societal practices to adopt AI yet, but it's here, so we're going to need to develop those practices. And the final point is this, and maybe the most important. I've been really gung-ho, as you can see, about AI because I think it is so transformative, but we have to remember that the data has limitations. It's just a facade of reality, not the real thing, in the same way that a map is not territory. And though we need to embrace data, it can't come at the expense of our wisdom, our judgment, our sense of fairness, our sense of common sense. I believe that we're wise enough people that we're going to find the right balance and do the right thing, notwithstanding a political environment that seems all to the contrary. But I'm still an optimist. What's the future going to look like? Companies that use AI are going to do really well, and companies that don't are going to have problems. Thanks a lot, and I'll stick around for a couple questions.